I have one last little tidbit to share with you to wrap up section 5.2, the natural exponential function. The function y equals e to the x qualifies to be an exponential function because it has a constant base. Now, if you've never seen the number e before, it has an approximate value 2.718. Now, e is an irrational number. What that means is that it is a non-terminating, non-repeating decimal. So e is an irrational number, which is a non-terminating, that means it goes on forever and ever, non-repeating, that means there's no pattern, and it is a decimal. It cannot be written as a fraction. E is what we call the natural base, and it's part of this natural exponential function. E is a number similar to pi. You may be familiar with the irrational number pi. Pi we often approximate at 3.14, but pi actually goes on forever and ever and ever without establishing a pattern. In the same way that we approximate the symbol pi with 3.14, we approximate the symbol e with the value 2.718. You can find e on your calculator above the divide button. If you'll type your second button followed by the divide key, it shows the e on your home screen, and pressing enter gives you an approximation for e. You can do the same thing with pi on your calculator. Pi is located there above your caret button. So e is approximately 2.718281828. Now I know that looks like a repeating pattern there, but the calculator is truncating the decimals for e. So if we were to look at the extended decimal value, there would not be a pattern there. Like pi, e is one of the most important irrational numbers as far as mathematical models go. Let's look at the graph of the exponential function. The graph of y equals e to the x is given. So notice it has the same basic shape as an increasing exponential function. Like our basic exponential functions, it has a lower boundary line or a horizontal asymptote on the x-axis with equation y equals 0. Notice there are 3 key points on this graph. As our exponential functions do, this has a y-intercept at 0, 1. The next point would have an x value of 1, a y value of e, or approximately 2.718. This point here has x value negative 1, and the y value is 1 over e, so a value less than 1. The domain of this function is the same as the domains of our exponential functions. That is negative infinity to infinity for the domain and 0 to infinity for the range. Now, if we look at graphing e on our calculator, we can go to our y equals. I mentioned before that there is an e above the divide button, but look on the left side of your keypad. There's also an e to the x function above your ln button. So to graph e to the x, I'm going to type my second key and then the e to the x button. I'll type in the exponent x and graph the function. And we're going to see a familiar graph here. This is the graph that we were just looking at. The purpose of this exercise is to compare the graph of e to the x with 2 to the x, another function that we have graphed previously. So the green function is e to the x, the red function is 2 to the x. Notice e to the x is just a little bit steeper than 2 to the x because 2.718 is a little bit larger than 2. As I mentioned before, e is a very important number when it comes to mathematical models. I'm sorry for the background noise. I've got a little remodeling going on in my house, so I'm sure you guys can hear the drilling and the sawing going on. The natural exponential function can be used to model phenomena such as radioactive decay, population growth, and continuous interest investments. So it's very interesting that your financial investments use E, as well as population growth and radioactive decay.